In this video, we'll go over a multiplication rule. We use the multiplication rule with multiple trials, and it's often referred to as the AND rule because we see the word AND in these types of problems, or you can reword the problem with the word AND, except for the fact that you need to pay attention to whether we mean AND as in both things happening once together in the same trial, or do we mean that we're doing multiple trials and the word and actually means and then? So A happens and then B happens. So if you can reword it A and then B, you should use the multiplication rule. When you use the multiplication rule, you multiply the probabilities together, being careful to adjust the probability of B so that if A happening before that made some kind of difference to whether or not B would happen, you are accounting for that. Right? Sometimes when one thing happens, it changes the likelihood of another thing happening. This is where we determine whether the trials are dependent or independent. Notice that conditional probability, which we covered in a previous video, shows up in the formula of the multiplication rule. So conditional probability and whether whether trials are dependent or independent are all related. So if we have independent trials, a series of trials are independent if the occurrence of one does not affect the probability of any other event that happens next. So when just thinking about two trials, the probability of B happening once we already know that A happened, does that probability of B stay the same? If it does, we say that they are independent. If it doesn't, if the trials are not independent, they are called dependent trials. And what will happen then is that the probability of B under the assumption that A has happened will be different than the usual probability of B without A having happened first. So then they're dependent if that probability is different. So independence is important to consider when using the multiplication rule. We don't think about independence when we're doing the addition rule. The addition rule, we have another concept to consider, which is the concept of whether or not events are mutually exclusive. So this is different. We'll be interested in independence when using the multiplication rule. So let's look at an example. So here's our experiment. Randomly draw one card and record whether it is a king, then put the card back in the deck. Shuffle, randomly select a card again, and record whether it is a king. So how many trials are we doing here? Are we doing one trial or multiple trials? We're doing multiple trials, so we should be using the multiplication rule. We have a favorable event of a king, and so we need to know the probability of a king, which is 4 cards out of 52 in the deck, or as a reduced fraction, 1 out of 13. So the probability of drawing a king on the first trial, putting the king back in the deck, shuffling, drawing another card, and then getting another king can be summarized as P of K, K. So this means K and then K. King and then king. We can calculate this using the multiplication rule, where we calculate the probability of getting a king on the first trial and then a king on the next trial under the assumption that the first card was a king. The probability of drawing a king, given that a king was already drawn on the first trial, is equal to the probability of drawing a king whether or not we already drew a king. And that's because of how our experiment was defined. We said that we were going to put the card back. So this is an example of with replacement so that the trials are independent. because now, after we've put that first king back into the deck, there will still be a probability of 4 out of 52. It will not have changed by taking one card out and having not put it back. So we just multiply the two probabilities, and then let's look at an example with dependent trials. Randomly draw one card and record whether it is a king. Keep that card out of the deck, then randomly select a second card and record whether it is a king. Favorable event, a king. The probability of a king in general is 4 out of 52, or 1 out of 13. We're missing a parenthesis here, but it should read P of k times P of k given k. So here, the probability of a king, given that we've already had a king, is not equal to the usual probability of getting a king, right? So this probability right here will not be equal to 4 out of 52. It will be a different probability because we already pulled out a king on the first try and didn't put it back. So as you can see on the first trial, the probability of a king is as it usually normally is, times the probability of a king on the second trial, where we only have 3 kings left in the deck out of only 51 cards left in the deck. So the summary of the previous counting rules, P of A or B is the inclusive or. We have to consider whether these events are mutually exclusive or not. The multiplication rule, P of A and then B with multiple trials, is the probability of P of A times P of B given that A has already happened, so we're considering whether events are independent. Right, so that's an overview. We also had conditional probability in there, but the two right here, I just want you to keep in mind, the addition rule, we think about mutually exclusive. The multiplication rule, we think about independence. Also with the addition rule, it's generally one trial. With the multiplication rule, it'll be multiple trials. So keep those two rules in their own separate category. Let's do more examples of the multiplication rule. In the next video.